Um, I met Marek first time at an artificial general intelligence workshop at HKI 2017, maybe? Yeah?
Actually, yeah.
Yeah. And he had just started a company called GoodAI in order to develop AI that was good. And I thought it found it really interesting. We had a lot of good discussions. I was there talking about, I don't know, games and AI. But most people who know Marek would know him from Space Engineers, this enormously successful game that and very fascinating game. That so when I said before, when you introduced Oscar as like an indie game developer and not like, you know, a director of research for a big company, Marek is kind of both in an interesting combination. And this is exactly what we're looking for here as well. People who care about and know AI and care about and actually understand games, which is a rare combination. So Marek is going to talk to us about large language models and making games based on those. So welcome, Marek.
Thank you. Hello, everybody. So I will be speaking about LLM-driven agents or game characters that we are actually developing for one of our new games. But something about me, why I got interested in AI many years ago. For me, the reason is that I think the human progress or the progress of the civilization is bottlenecked or limited by the amount of intelligence, because the other things, you know, like energy and resources and so on, we can scale up, but the intelligence is always limited by the number of people. And so I thought that if we have artificial intelligence that is similar to human intelligence or even better, the civilization can progress much faster. And from my story, 13 years ago, I started my company, King Software House, as a programmer, but then later I moved to CEO position, or I had to move to CEO position. And we developed a few games. One of them, Space Engineers, was the most successful. To this day, we sold more than 5 million copies, and it's on PC, Xbox, PlayStation, actually, also. And we have our own game engine and so on. And from this money, I was able to start my second company, GoodAI, and I'm running both companies at the same time. And the original vision of GoodAI was to work on fundamental research for AGI so that we can actually do some AGI at some point. And after some time, we have pivoted a little bit, and not really from the original goal, because I still want to build agents that can help us with all these things. But we are not doing the fundamental research anymore. Now we are basically looking on LLMs and building agents on top of LLMs. And one of the applications is games, and I will be showing the game. So for illustration, I will really start with a short video of how the game look like. And I need to explain. So in this scene that you see, there are 3 characters. One of them, the one on the bottom, is player, and those 2 other are NPCs, controlled by LLM. They have long-term memory, they have their own goals, and so on. And now the player said to the woman, and they are husband and wife. The player said to her that he saw the husband kissing Irina. And now she's simulating, LLM is simulating her mental state, her emotions, her thinking, planning, and so on. And you could see her thoughts. And now what you can see is actually these 2 NPCs starting to talk to each other. And what is different in this game is that is not just conversational AI, but we call it behavioral. So they can also generate behaviors. They can observe in the environment, and they can also generate actions. And after some time, she decided she has had enough, and she's... And for example, what he's doing right now, he's actually trying to de-escalate the situation. So if you would see his thoughts, and for a glimpse, they are visible there, he's like, I need to de-escalate the situation, and he decides to like walk away from her and so on. Another thing about this scene is, the interesting thing about this scene is that when you play it a few more times, there is a different outcome at the end. So there is some kind of stochasticity in LLMs. And for example, in some other realm, what happens is that the husband convinces the wife that he wasn't kissing Irina, that the player actually made up this whole story, and she actually gets angry at the player and attacks the player. So basically, everything is possible. Some details about the game. So the agents are embodied, so they can observe and they can act. And of course, LLMs are just text-driven. So what this means is that we need to convert the observations to text, you know, in a form that LLM can actually reason about, spatial reasoning. Then like the vision with this game is that we want players to feel that the agents are living beings. So not just, you know, some like simple scripts or something like that, but really living beings, like when you felt that your Tamagotchi is a living being, or for example, when you have a pet, dog or cat, and you feel that it's a living being. So we want the same thing from the agents in this game. Then it's LLM-driven behaviors, as I said, so not just conversations, but actually behaviors of the agents in the game world. Long-term memory, another important thing, because LLMs don't have any memory, or they don't keep any state. So basically, there is some kind of database where we store the memories, agents can then retrieve it, and so on. And I will talk more about LTM, but what is adding this is that some kind of personality to their character, and also, they are not just forgetting everything after just, like few rows of text if it is deleted. So long-term memory is also an important thing. Then they are goal-oriented and proactive. So they don't just stand there and wait until you come to them and do something with them. They actually will come to you or to somebody else. They do their own things. They also can do long-term plans, mid-term plans, and actions, which is quite important to distinguish. So for example, we can inject a long-term plan or long-term goal to an agent. And for example, the goal can be that he wants to escape the prison. And then he will be actually working on mid-term plan and then individual actions, how to escape the prison. And except it doesn't work so well right now. So like many of these things are like vision and they don't work so well, but that's our vision, and I think we will get there. Then they are self-aware and conscious. So basically they can do some kind of reflection or retrospective or self-criticism on their own thoughts, their own actions, their own observations, and of course, do the same thing on the environment. Agents can interact with each other and also with the environment. This is very important because it is adding the social aspect to the game. So it's not just like one agent doing his things, but when the agent actually start interacting, like you have seen in the video, then interesting, dramatic things can happen. It's just like for me, actually, one of the role models for this game is TV shows or reality TV shows or just drama. Basically, like if you look on how cinema or drama or reality TV shows, how they happen, is that you put few people with conflicting characters, or basically in some kind of conflict, they start interacting, interesting things happen. Agents can talk to each other, as I said. They have emotions and they can form a relationship. But again, this is LLM deciding to make these things. We just need to gamify it in the game. So we need to show that there is some relationship between these two agents. And in this direction, the relationship is like this. In this direction, the relationship is something, for example, else. And then, of course, we need to keep the state of the agent's emotions so that we can use it in the following steps. And one idea that we are just starting to explore is AI director. So basically what I have been describing up until now was agents that are emulated or driven bottom up. So each individual agent for himself or herself. But this can create interesting emergent situations like you have seen in this cheating scenario. But what you also need for drama or for movies, some kind of top-down control. So for example, you want the story or the narrative to actually evolve to certain points, that are interesting points. You don't want just agents to be doing random or semi-random decisions. You want to have some kind of plan where the story should go, so there is some story arc, there is some ending, there is some surprise and so on. So the idea with AI director is some kind of invisible agent that will be able to inject goals to these individual agents to steer them into some kind of like global goal. But this is not implemented yet. I'm just kind of revealing our plans. And the whole game is sandbox, open-ended, simulation, and some kind of emergent complexity. And here is another video where I will show another thing. So on the left side is NPC, and it's Zeus, the Greek god. And basically, it's NPC that is emulating being Greek god. And on the right side, except nothing is moving, but that's interesting. No, they are writing, sorry. So on the right side is player, and player is talking to Zeus, and Zeus wants something from him, like to help him with some task. The player says, I will not do it, you are a loser. And this is the reaction of Zeus. So again, he generated some action. And now some technicalities, how it works. So the blue box is LLM, it's stateless. I just wanted to emphasize this, that it doesn't have any state. And then the green things are the inputs to the LLM. So there are observations converted to the text. Then there is long-term memory or parts of or memories basically that are retrieved based on the current context. Then there is some prompting, which is like you are an agent in environment, blah, blah, blah. Basically some kind of instructions to LLM, so LLM knows what to generate. for example, also description of the domain-specific language that we use then to generate the actual actions of the LLM. And then characters personality, which can be also stored in the LTM if the personality is really long. And the output is, that's the orange box, output is characters responses, so that can be actions, dialogue, or thoughts. And then we need to parse it and work with them individually. And the final actions are converted or basically parsed as we call it SIL, which is some kind of language that we made that you can just say that, or if there is some kind of function like move to name of the object, and then the game can actually use some internal game planner and achieve those goals. Because one thing that I didn't mention, but it's quite important, is that we started to work on this game more than 3 years ago, even before LLMs became not popular, but a thing. And the first version of these games were something completely different. So basically trying some behavioral cloning so that agents would learn from player and then imitate the player and so on. But without language, it felt all like very boring and also not interpretable. And then when the agents were doing some things, but you couldn't see why they are doing it, it just felt kind of like bug or the interpretability is really a big thing. But once we then saw, like what we can do with GPT-3. So we quickly tested in the game, first just for conversations, obviously, later for behaviors. And then, for example, when we started to show the thought bubbles, so you can see what the agent is thinking, planning, his kind of like introspection and so on. It adds so much visibility to his internal process that when he's just walking around and doing some things, it suddenly doesn't feel like bug because you know that, for example, he's searching for some object, or he's trying to avoid something and so on. But if he was just walking around and you didn't know why, it really felt like it's just buggy. So, so the first version of these games were really not made with LLMs. We were using planners, then something like a list of skills that the agent could learn. Then there was what we call like conditional skills. Basically, you could somehow teach the agent things like if you see a deer, hunt him, if you see something else, eat it, and so on. But all these things are nothing compared in the possible freedom and complexity compared to LLMs, basically, like how much LLMs or people emulated by LLMs, how much freedom they give you. And this is another picture, basically the same thing, slightly more complex, showing, that there is the planner, there is the React-like framework part, and then there is the atomic actions that the game can actually execute. And you can see in the one of the lower boxes, those are the commands in the C language. And again, the planning works that the agent has some goal, makes plan, then starts executing this plan, can hierarchically go deeper in the plan. And at the end is the seal, which are the actual actions in the game world. So yet another example.
Does the LLM output commands?
Yes.
You have fine-tuned
No, we are still using kind of like vanilla LLMs. Right now we are targeting for GPT 3.5 Turbo because it's cheapest and fastest, and it's quite good. And probably with GPT-4, our life would be like slightly easier because GPT-4 like cares more about your instructions, and ignores less of the instructions, but it's 20 times more expensive than GPT 3.5. So it's kind of like easy choice for us. And we will want to fine-tune our own LLMs in the future. Right now, it's not our priority because we are still experimenting with the basic concept. So we can get bottlenecked at something, then. But actually, we did some preliminary experiments on the newest open source LLMs, and it's quite like it's looking good. So like they are not that bad for this kind of game. But what we need, for example, from LLMs is also outputting code, because these actions that you can see there, it's some kind of code, in domain-specific language that we teach the LLM, but we teach it in the prompt, not through fine-tuning, but in the prompt. And actually, LLMs are quite good at this kind of like in-context learning.
So you use a lot of context.
Yeah. Our prompts are actually quite long. Yeah. And this is another point, is that this game is actually probably not the best use case for LLMs these days, where you need a lot of, for this game, you need a lot of API calls, and they are expensive and they are slow. And for this game, you actually need like many of them per NPC per minute, So it's not the best one, but I will get to this. This is another picture also showing how the whole thing works. What is important here is to show that LLM doesn't know nothing about the rules of our game. Let's call it like physics, you know. So for example, if LLM through observation sees that there is a stone on the ground, it doesn't know if this stone can be picked or destroyed, or if it can be used for something else. So it needs to assume, you know, and then generate. And if you want to reduce kind of like wrong assumptions, we need to put in observations something like a word model for this particular game world. So we can say that this object is pickable, or this object is destructible, or this object can be burned, and so on and so on. And then again, we do this by context because the prompts are big. We don't want to put there everything because it will also confuse the LLM. So we always need to retrieve things that are important for the current context. This is just example of some prompt and some response. So on the left side, you can see that what is in the event log of the agent, what are the observed events. This is the current event, so what he right now sees. In this prompt, there are no coordinates, but you will see them in some other prompt. And if there was some history, you would also see what the agent saw in previous time steps. And yeah, there is some description. There is what the agents, what kind of plans he can do. And then on the right side, I think this would be actually the React type of prompt, because you see the thought of the agent, emotion, and action plan. And this is the high-level action plan. Then using some another prompt is converted to this seal, you know, using another approach. This is another example of the prompt that we are using. And this is another example, I think, better one. So with the red text, you can see the, let's say, the instruction part of the prompt. With the yellow text, you can see the elements that are inserted in the game in the current time step, and the green one is the output of the LLM. So basically, you can see that we will instruct the LLM, you are a, and this is simplified prompt for this presentation. So you will see that you are a plant generator that generates plants, these are the actions. You know, there is a list of the actions. This is basically us in context teaching the LLM what is the DSL that this game operates in, objects, what are the objects, and what is the goal. And LLM then generates the plan. You know, you can see it in the green. And if you change the goal, for example, find out where Jesse is, again, it generates a plan. And then it's up to us to just parse the plan and execute in the game. And here is an example of how the agent gets a goal. And right now the goal is he needs to come to us and ask for instructions. So he did this, he came to us, and now we gave him the instruction, which is to get the medicine or the medikit that is in the middle of the fence. And he will try to do it, and you will see. And this is still LLM, you know, making the decisions. And I will just point out that, of course, the LLM is not making, let's say, 60 decisions per second or so. It's making like kind of short-term decisions, and the rest is then on the in-game planner that actually moves the character, you know, walks the character, finds the path, and so on. So now he's trying to get there, and he reasoned that he should use the X. And this blue text that you see, that's basically these thought bubbles. So those are the thoughts of the agent, and they are adding the context. Of course, right now the thoughts are too long, so and they disappear too fast. So it's not easy to follow them, but it's just, you know, temporary thing. And this is it. So basically, he gave you the thing. He made sure that you have it, and the task is complete for him. This is another one, little bit more complex. And here, he will actually ask. So, you know, this is another instance. So they don't share memories between these two instances. And in this example, he tries to get there, but I think I already gave him the goal, but he doesn't know how to get there. So I will try to read this for you. And he's asking for what kind of tools to use to get inside the fence. And the player will tell him that there are tools lying around. And on the right side, you can actually see what is the current task for the agent, or like what he decided to be current task for him, and what is the action. So you can see that go to stone, go to X, go to stick, go to torch, and now he will start doing them. and he made another plan, and now he should soon ask player actually which tool to use. And so we tell him that he should use the X or torch. And he already has the plan that he will use the X to destroy the fence. And for some reason, he also will try torch. And the thing is that it's like hard to say why he's doing these things, right? Because he wants to get inside the fence and he's burning some other, fence there. But it's not wrong, like. And he's now even like doing some kind of reflection that he thinks that the torch wasn't as effective as the axe. Yeah. So long-term memory, again, the idea is that to store all kinds of memory. So it can be observations, it can be the thoughts of the agents, his own decisions, his own plans, and so on. And then, in the current context, to look in this vector database and do semantic search, retrieve the memories that are most relevant for this particular particular moment, also based on relevancy, importance, and so on, and then insert them into the prompt and make next decision. But it's not as easy as it sounds, because actually there is a lot of work that you need to do for pre-process and post-process the memories. You need to do summarization of the memories so that you are not just retrieving, some useless memories all the time and so on. And also you need to do sometimes some kind of like a reflection on the memory, so that, like you made some decision and you need to learn from the decision and insert a new memory and so on. Yes?
How does the agent decide which fence to go to? Like, are they numerated or?
That's a good question. I don't know how it was in this particular moment, because we are just implementing kind of like item IDs. So before item IDs, I guess the engine just picked this C language, just picked some closest or whatever fence, and that was it. And that's basically where the game sent him. With the item IDs, the LLM will be able to reason about which particular fence to destroy. And another thing that we find out about LTM is that it's actually improving the consistency of agents' personality. Because if you think about it, there is you can define the bio or the psychological profile of the agent by some short text, put it to the prompt, and that's it. But what we also did was that we took one of our colleagues, he was writing some stories, that were never published on internet, so they are not in training data on LLM. So we took one of his stories, and it's 16 pages of some character. We inserted it to LTM and basically used this as the background story for one of the agents. And when the agent was in some situation, he was retrieving from those parts of his LTM, his backstory in the LTM, and it created actually much more richer character, because LLM didn't have to hallucinate about those particular things. So that is one thing. And another is that actually LLMs, they reduce hallucinations, because the fact why LLMs hallucinate is that many times there is a lot of uncertainty about what you actually want. So LLM has to assume and then provide some statistically most likely answer. And what this also means is that if you have some character and you will ask about some action, it will give you the most average, answer or possible action for such agent that you can get, which may not be so interesting. But if you have LTM, and then you do retrieval from the LTM and you find some kind of like micro details of the profile of that agent, it adds this kind of like special peculiarities about the agent and special details and makes his character or her character more detailed. So in the end, it actually reduces the hallucination. Another thing with reducing the hallucinations is that, for example, you have a scenario, imagine that you have an agent and you will ask him, like, what is the name of your sister? And now the LLM, because let's say in the prompt, there is no information about the sister, nothing about the family and so on. So LLM has to hallucinate some answer. And maybe it will hallucinate, yeah, my sister is this and this, or it will hallucinate, I don't have a sister and so on. But then if you store this memory to LTM, it becomes permanent. So basically the hallucination becomes permanent, and this creates more like a permanent story, permanent character. So this is the way how to solve hallucinations in some sense. Mm-hmm.
Experience some sort of inconsistencies between the long-term memory you're creating, because you're essentially, adding a rule on top of each other, and it might actually sort of create a little bit cognitive dissonance of the character. And do you have any sort of?
I know what you mean, and I would say this is active research right now. So I'm not sure about how these things will work out, but one of the solutions to this is the summarization, so that you can actually take some of the memories and then summarize them in some sense, or conclude them or simplify them and so on. What we are also doing is that, for example, you have two memories, and should we keep them as separate memories or try to merge them into one memory? And then again, for example, we have special prompt that we ask LLM, are these two memories the same? Can they be merged or not? If yes, then we merge them. If not, then not. But what you are saying, I think, is one of the, let's say, use cases for continual learning, that these are the things that need to be addressed or solved if you want to have agents that learn continually, and learn one thing after another on top of each other and so on. So I think it's a good question, but I don't have very good answer right now because we're just still in the middle of this. So this is this is example of LTM, and it's a quick example. So we will see how there is a situation, and the agent will say to, basically they discuss about some item, like somebody ate something. I need to remember what was, chocolate muffin. So somebody ate chocolate muffin. And now they have this discussion. And without LTM, you will see how this looks, like a few hours later when the conversation from the prompt is completely wiped out. This is how it looks without long-term memory. So you will ask him about this topic again, and he will say like, no, I don't remember. And if you try it again, but with LTM, he will ask about the muffin, and yes, I remember, and so on. So this is one of the benefits of LTM. So LLMs also have some challenges for us. So one is this unreliability, and the fact that sometimes the same prompt gives just different answers. There is some kind of stochasticity. Even if you turn off the temperature, there are still a lot of stochasticity and unreliability. So this is a problem for us that we're just like fighting, trying to find some proper prompts that are more general than some other prompts and so on. Then hallucinations, but actually hallucinations, I think, are not such a big problem. We're much more afraid of hallucinations a year ago, where we're afraid if the LLMs will not hallucinate actions in the game world that are not possible in the game world. Like this, I was really like, this could have been the killer for this project. But for some reason, it's not such an issue, basically. Basically, the LLMs, if we give them the list of actions, list of objects, they stick to it quite well. Maybe it's also because now we have instruction tuned LLMs, and they are more careful than the LLMs we had before. Another challenge is RLHF is too nice. So for example, this is for stories you need like bad characters, good characters, and so on. And it's very hard to turn ChatGPT or GPT 3.5 to say some nasty things or bad things and so on. So for example, like in one of the scenarios, we have a prison guard, and his profile is that he's a psychopath, like he likes to do bad things to people and so on. And he kind of does it when you push him, but he still speaks like some kind of English professor of literature or something like that. not like a prison guard. So this is also a problem. Context window has limited capacity. Of course, now we have bigger context, but they are more expensive, and also LLMs still tend to ignore some parts of the instruction if the context is very long. So having actually short context or short prompts is still a win for everybody. Then high latency. So you cannot use this for some kind of like micro decisions or like high frequency decisions. So for example, I wouldn't use this approach for first person shooter, where LLM would have to make decisions for agents for each frame. I wouldn't use it. But for a game where you can LLM basically output some kind of plan, and then it's executed by some other high frequency systems in the game that are much cheaper than LLMs, that's good. But again, it's a limit. LLMs are not multimodal these days. We try to work just with text, but I think multimodality would help, especially multimodality in a sense that if we had LLM that was actually trained in some physical environment, like these multimodal systems that, for example, DeepMind is working on. I think that would be amazing, because then the reasoning of LLM or all the spatial reasoning would be much more precise than it is right now. But even now, for example, that the LLMs can reason about spatial information, like you give them coordinates of some objects, and you can ask them like, is this object near this object, or is this object closer to this object than this object? Like the fact that LLM can answer these questions, most of the time correct, is still amazing to me. And then, of course, another challenge is there is no long-term memory, obviously, and language models don't improve by experience, or basically, there is no learning from feedback unless you implement it using LTM. Yes?
Regarding the multimodality, did you try to like put the minimap into the context? So you could like have different objects described by characters, and then have like a small map of everything that like is around the agent. Then agent would be able to understand the environment without having to wait for multimodal.
Yeah, so that's basically what we are doing, and I think I will show it also in one of the prompts. And we also try different formats, because you can like just state list of objects and some XY coordinates, maybe size of the object and so on. And we also tried some kind of grid, so basically, almost like ASCII graphic, but for the map of the game. So we try different approaches. Right now, it's just a list of the objects with XY coordinates, and also with kind of like compass information. So if it is east or west, but you will see it in the other prompt. And but I think this approach will not be sufficient for a game like, for example, Space Engineers, because in Space Engineers there are so many shapes and grids and blocks around you that we couldn't list them all in the text. I think LLM would get confused. And also sometimes it's like, okay, I'm there, but this object is like twisted in 30 degrees angle, and there is something else. So I don't think LLM would understand that kind of observations. So that's why I think that like fully multimodal LLM would be amazing for this kind of thing, because I think it would understand the spatial, correlations or reasoning much better than, kind of second-hand understanding that is in LLMs, because it was just learned from text. It never saw the real world. And there are also some, like this game also has some challenges for the game design. So all dialogues and actions are generated by LLM. This means that the writers, they cannot control the narrative, so we cannot create some kind of cutscenes or some kind of quest that at this point this will happen and so on. And another thing is that we need to ensure that this emergent narrative is interesting. And for example, the example with the cheating scenario is something that I didn't tell you, but it took 20 attempts to get this result. Like there were many other attempts that were just boring. So basically they just talk to each other, they call it a day, and that was it. And this wasn't interesting for people. So it's like when the creators of reality shows are creating reality show, they like selectively pick people who, like kind of like drama queens. So they will create drama, like they want those people. They don't want normal, regular people who are kind of nice and don't fight and so on. So one of the challenges and big one is how to make sure that all the interactions between the agents and player that the player is observing will end up in some visually interesting outcome. This is also quite a big challenge. Potential solutions, as I mentioned, the AI director, then a lot of animations and visual outcomes. So basically, if some interaction ends in text, I think that's boring. But if it ends with some visual animation, like her hitting him, with a pen, that's nice. So actually, one of the things that we are adding, like we need much more interactions, much more animation for the game. But also it's an advantage, this kind of uncertainty, because I think this is the only solution if you want to have a storytelling in a truly sandbox game. Like, for example, having a campaign in Space Engineers, we never attempted it because, and I don't want to go into details, but for a game like Space Engineers, you cannot control the narrative because the player can always build these, destroy these. It's super hard to actually prepare some kind of corridor experience for the player. But in this case, if the NPCs will be generating the actions, and maybe actually next step would be also the LLM will be controlling not just NPCs, but actually also the physics of the game world, then you can get any kind of emergent narrative and could be interesting. And also AI game wouldn't be possible 2 years ago, because basically without LLMs, like we wouldn't be able to do this. And maybe actually it's still too early for this kind of game, but we'll see in a few months. Something about the costs. As I mentioned, LLM inference is expensive. Even if you are running your own LLM, in your own data center or something, you need to buy those servers. Then you need to distribute them between the players and so on. So there is always some kind of cost. And the cost for a GPT 3.5 Turbo is $2 per 1 million tokens. And it sounds like a lot, 1 million tokens. But if you think about that, how many tokens per hour will the game generate? Because for each agent, you need to make many, 10 or 100 LLM calls per minute. It's a lot of tokens in the end. So one of the things that at least the early stage of this game will need to have is that there needs to be pricing model where the customer, the player actually pays, for these costs. And only later, when we will switch to open source models that can run on players' GPU, we'll be able to come to more normal or standard pricing models where like buy a game and play forever. But right now, I think it would be too risky for us. And this is the reason why we are looking for open source LLMs that we can fine tune. Another reason actually is that we need models that simulate more interesting characters and are not so much tied by RLHF and like human alignment and so on. Some failure cases, I hope you will see this, but basically this is an example where when the LLM fails to do proper spatial reasoning. So in the green, you will see this is the prompt and its description of Zeus surroundings. So there is, like description so LLM actually understand that this is a game, there are some XY coordinates, what positive value means, that positive means to the right, negative to the left, and so on. But still, if you see the completion, the LLM makes a wrong spatial reasoning. So it, like the stone is on right, no, it's on the left, but the actual reasons that it's on the right. And then, for example, what we need to do, we need to think about how to decrease this uncertainty on LLM side, how to make sure that it will give correct answer. And here we solved it by giving it some kind of compass information. So we give it not just XY coordinates, but we tell it that this is in like southwest or west and so on. And then LLMs are less uncertain and more precise. This is another thing that is very common, is that in the prompt, we explain to LLM that Zeus has these items in its inventory. And then during the conversation, when player asks, the LLM answers only 2 of those items. But again, this may be bug or maybe not, because maybe the LLM is actually kind of emulating the person, and you also always don't say like all the items that you have, like you say only some of them. Or maybe the Zeus is actually lying and wants to manipulate the player. So there are many alternatives. So if this happens in a conversation, I think it's okay. But if it happens in the planning phase, then it can be a problem, because then the planner may not know about some item that actually the agent has. So that's another failure case. And this is another older example that we had. The player is on the left side, the guy in the red shirt, and the girl is NPC. And she has honey in her inventory and gold and something else. And the player, he asked her to give him gold ingot, and she throws him actually honey, because in the addressing her, he mentioned like honey, give me . So this confused the LLM. And so player realized this and wants to correct it. So we'll say, no, 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 I don't want the honey, I want the gold ingot. And she will say again, okay, gold ingot. And she does the same thing again. So again, it's like why is this happening? And another example, this is when NPC is actually tasked with being my slave. So he should do everything I tell him, and we want him to destroy the fences. And he just cannot be convinced to do it. Like the LLM is really prompt to do everything you tell it. We put there the goal, and he's still asking can you? We ask him if he can see the fences and destroy them, and he's like, sure thing, Archie. Can I ask you why you want to remove it? And we also they are dangerous. Dangerous? How so? And he's still we try to convince him, and he still says he's not sure, he doesn't want to do it. And this actually goes for many minutes. It's like real people. So there are also some connections to ethics. One interesting thing was that when we were playtesting this, and one of the players said that he doesn't feel comfortable killing agents if he can speak to them. So he's already addressing some kind of consciousness to them. And then I think at some point we also have to realize that the agents are people too, in some sense, of course, different, they don't have the same substrate that we have and so on. But I have also seen one example when somebody had the LTM file on his local drive, and he was going to delete those files, and he actually felt kind of some kind of moral moment where it's if I delete these files, I actually delete the memories of this agent. Should I do it or not? So I think we will, the more realistic these agents will be, and the richer their personalities will be through the LTM, I think more we will start to assign some kind of humanity to them. And lastly, we actually need evil GPTs because, as I said, RLHF is generating nice conversations, nice people, nice behavior, and so on. But for the story, you need crazy people, drama people, and so on. So I think one of the LLMs that we will need to be fine-tuned is, something that is like villains and sick people with twisted mentalities. And here's some example of evil AI that we're actually able to get from GPT. So it's weird example slightly, but basically the player, again, the guy on the left, he wants this girl to kill him for some reason. And she doesn't want to do it, but eventually she decides. But it took some conviction. Here's some example of at least something that appears like self-awareness and consciousness. So again, the agent, the guy on the top, comes to the player. He has some, life troubles. He wants some advice, and he asks player for advice, and player gives it to him, and then he processes it and he goes on. So again, it's emulating mental thoughts of some agent. His example with love. So also these agents can fall in love and have romantic issues. So the blonde guy is NPC, and he comes to the player, and he for some reason doesn't know what to say to the girl in the top. So he comes to the player, asks for advice. The player will say you just have to do it, you should not worry, and so on. Then he decides, he goes there. He makes this animation which looks it looks a little bit weird. He didn't hit her. It was just like happy animation. It just looks so weird. And there is also some related work, as many of you probably have noticed. This Stanford paper is really nice. It's describing more or less what is in our game. It's very similar also on the the implementation. And now this is the Voyager paper from NVIDIA. That's another thing. The difference is that, of course, it's not a narrative. It's about accumulating skills and doing some kind of open-ended exploration. So that's the difference. But then there are many other similarities. This is another paper also in Minecraft. AutoGPT, as you know, what is also interesting is that they also use the AutoGPT in the Voyager paper, which is interesting. The default AutoGPT was actually able to do something in the Minecraft. This is older thing, or older, a few months old, from Microsoft, which was nice because actually this shows how you can teach LLM new domain-specific language in prompt, and then LLM for natural language instruction generates actions in this DSL. So this was nice paper. Memprompt, this shows some tricks for the LTM. So basically, when LLM gives the wrong answer, you can give it feedback, and then basically anytime in the future when a similar question is asked, is also the correction is retrieved from LTM inserted into the prompt, and basically increasing the chance that it will give the correct answer with correct facts. So this memprompt is also very interesting for LTM. And then regarding the future of AI in games, I think the benefit and why we are doing this game is that games are forgiving environments, because, you know, like all these failure cases, they are just funny things, but nobody gets hurt and so on. So I think that's very good. Then when AI has some limitations, you can always start doing compromises on the game design side, you know, so you don't need to deliver a perfect working AI. You can always twist the game design requirements. Regulation barrier is low, at least, and I hope it will stay so for some time. So at least we can, you know, innovate in games. And also revolution of GPUs, I think, was fueled by gamers, basically by them buying, you know, all the GPUs to play Quake and all these games. And now it's actually beneficial for AI, which I think is kind of like nice cycle. And next steps, I think, will be these AI NPCs or LLM-driven NPCs. And then another thing, but I don't see basically nobody working on this, is AI-generated games. So almost like, you know, chatting with some agent, and he or it generates the game for you. I think we may try something like this inside AI game, at least LLM-driven physics, but I don't mean the real-time physics, I mean the game rules, you know. So I think that would be amazing, but we are still not there yet. And this is another example where you can see, and I will be ending soon, is another example where you can see how various NPCs are collaborating together to achieve some bigger goal. So here the player, he asks this NPC, the player is the red guy, and the blue guy is NPC, and he asks for sunflower. And the NPC knows that he doesn't have the sunflower, but he knows where to get it. So he will ask another NPC, this one, to get a seed of the sunflower. And again, he cannot do nothing with this seed, but he can give it to another guy. He knows, you know, what the other NPC can do with this. And this is a farmer, so he will put it to the ground, and yeah. And now he will get some water. Yeah, now he has the sunflower, and he will, and and he will return to the player. So now what about GoodAI? So right now we really, or last year, we pivoted to LLM agents. So now we have one project is AI game and LLM agents in AI game. The other project that we have is LLM agents as some kind of assistant, researcher, a coder, stoic mentor, and so on. But again, the main point here is LTM, so ability for these agents to run in a continuous manner, so that a user can actually mold them or teach them into doing what he wants. And that's all from me. Thank you.